Okay, Wildcats. Today we're looking at journal page 13, solving absolute value functions. Now, start with the definition of absolute value of x. So, x when x is greater than or equal to 0, and negative x when x is less than or equal to 0. Solving steps. Step 1, isolate the absolute value. Step 2, graph the left side. Step 2, graph the right side. Step 4, find the x values of the intersection. Okay, types of absolute value function solutions. So it's no solution when there's no intersection and the absolute value of x equals a negative number. There's one solution when there's one intersection and the absolute value of x equals 0. There's two solutions when there's two intersections and the absolute value of x equals a positive number. Okay, so if you would finish up your notes. Okay, now your notes are completed. Let's take a look at the examples. Now, I'll start off. It appears that when these copies are made that it kind of got slanted somehow, but in essence, let's save a tree and use what we have, okay? So solving absolute value equations using the graph. Solve the absolute value equation below. So first step, isolate the absolute value. You can see the absolute value of x is isolated. So now we graph the left side. Well, that's the parent function. So let's use when x is negative 2, negative 1, 0, 1, 2. Okay, so the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Okay, so let's graph those points. So we go negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Now, we know that we can, the other points are 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, so on, 10, 10. Okay? And then negative 3, 3, negative 4, 4, negative 5, 5, and so on. And you want to graph every point that you can because it's going to make finding the intersection easy when you have the points. Okay? All right, now we graph the right side. So we graph a horizontal line at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now you can see it intersects here and here. So we're finding the x values of an intersection. So it appears that the x is negative 8 and x equals positive 8. Okay, let's look at example 2. Okay, we isolate the absolute value, which it is. So now we graph the left side. So we can see here it's an absolute value transformation, so we're going to graph by direction. Okay, so we know that the parent function starts at 0, 0, but that plus 1 moves the vertices left 1 unit. And we know the points from the parent function are directions, what give the absolute value its shape, so that's what we're going to use. Now, it's not 0, 0, it's hk, because the vertex moved. So from here, we're going to go left 2, up 2, left 1, up 1, from the vertex, right 1, up 1, right 2, up 2. And we know we can go 3, 3, 4, 4, 5, 5. So left 4, 4, left 5, 5, and so on. Left, what is it? Left 3, 3, and left 4, 4. Okay. All right, now we graph the horizontal line at 3. So that's the right side, 1, 2, 3. We see here it intersects here and here, so we're looking for the x values. So x is negative 4 and x is 2. Okay, so finish up example 1 and 2. All right, let's take a look at example 3. All right, we need to isolate the absolute value. So we need to add 1 to both sides, so the absolute value of x equals 4. And the absolute value is isolated, so now we're going to graph the left side. Well, that's just the parent function, so we know the points are negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. So we go left 2, up 2, left 1, up 1, 0, 0. And it says these are actually points, so we're actually putting the point at negative 1, 1, negative 2, 2. and then 0.1122. And then there's 3, 3 is a point, 4, 4, 5, 5, negative 2, negative 3, 3 is a point, negative 4, 4 is a point, and negative 5, 5. These are points, not directions, because it's the parent function, okay? Okay, now we have a horizontal line at 4, so 1, 2, 3, 4. So here's our intersection, here's our intersection. So our x values are negative 4 and 4. Okay, so finish up example 3. Okay, example 4, we need to isolate the absolute values. We need to subtract 3 from both sides. Well, when you do that, that becomes 0 and this becomes 0. So the absolute value of x equals 0. Okay, well, the absolute value of x is just the parent function, so our points are negative 2. And so we're now not graphing by, and actually, let me change that too. We were graphing directions, but once we isolate the absolute value, this became the parent function. So these are actual points. Same thing here. These are actual points. Okay, so negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Okay, so negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, and we can go 3, 3, 4, 4, 5, 5, negative 3, 3, negative 4, 4, negative 5, 5. Okay. Now, when you're graphing the right side, make sure that you graph the new right side, not the original. So here we're going to have a horizontal line at 0. So it intersects once when x equals 0. Okay, so finish up example 3 and 4. All right, let's take a look at example 5. Now, I think somehow this equation got cut out or removed, so we're just going to write it in. So the equation is 3 halves, absolute value of x minus 1 equals 3. Okay, now first up, we need to isolate the absolute value. So what we need to do is multiply both sides by 2/3. Okay. Well, when you do that, 2 times 3 is 6, 3 times 2 is 6, 6 divided by 6 is 1, so you're left with 1 times the absolute value of x minus 1 equals 3 times 2 is 6, 6 divided by 2, or I'm sorry, 6 divided by 3 is 2, so you have the absolute value of x minus 1 equals 2. All right, so now we're going to graph by direction, but we need to first move the vertex. So we were at 0, 0. That minus 1 moves the vertex right 1 unit. And then we know the graph by direction is negative 2, 2, 1, hk, because the vertex moved. 1, 1, 2, 2. Now these are directions, not points. Okay, so from here we need to go left 2, up 2. So from this vertex we need to go left 1, up 1. From this vertex we need to go right 1, up 1. From this vertex we need to go right 2, up 2. So then we know we can go right 3, up 3, right 4, up 4. Left 3, up 3, left 4, up 4, left 5, up 5. Okay. Now, we have a horizontal line at 2, so 1, 2. So we have an intersection here and here, and we're looking for the x values. So draw a vertical line down to the x-axis. So it looks like x is negative 1, and x equals 1, 2. Actually, no, let me recount. 1, 2, 3. X equals 3. All right, so finish up example 5. All right, example 6. Okay, so we need to first isolate the absolute values. We need to divide both sides by negative 1. So when you do that, you get absolute value of x plus 1 equal to negative 3. Now that the absolute value is isolated, we're going to graph the left side by direction. So we know it's negative 2, 2, negative 1, 1. Now for the vertex, the plus 1 moves the vertex left 1. Okay, so there's a new vertex. 1, 1, 2, 2. So from this vertex, we're going to go left 2, up 2. Left 1, up 1. Right 1, up 1. Right 2, up 2. And we can go right 3, up 3. Right 4, up 4. Right 5, up 5. Left 1, 2. Let's see. Left, up, left, up. Basically makes the V shape. Okay. Okay. Now remember, don't graph the original right side. The new right side is negative 3. So negative 1, 2, 3. We have a horizontal line at negative 3. Try to do it without a ruler. It just didn't work. So let's try it again. There you go. All right. You can see here that they do not intersect. When they don't intersect, it's no solution.